Force is a fundamental concept in physics, defined as any interaction that can change the motion of an object. Think of it as a push or pull that can make something accelerate, decelerate, change direction, or even deform. It's all around us, influencing everything we do. One of the key aspects of force is that it's a vector quantity. This means it has both magnitude, which refers to its strength, and direction, which tells us where it's applied. For example, if you push a shopping cart, the force you exert has a certain strength and is directed forward. If you push harder, you increase the magnitude of the force, causing the cart to accelerate faster. To understand how forces work, we can look at Newton's laws of motion. The first law states that an object at rest stays at rest, and an object in motion stays in motion unless acted upon by a net external force. This is why a ball sitting on the ground won't roll away unless you kick it. The second law tells us that the acceleration of an object depends on the mass of the object and the amount of force applied. This is captured in the formula F equals ma, where F is force, m is mass, and is acceleration. The third law states that for every action, there is an equal and opposite reaction. So, when you jump off a small boat, you push the boat backward as you propel yourself forward. The SI unit of force is the Newton, abbreviated as N. 1 Newton is defined as the force required to accelerate a 1 kilogram mass by 1 meter per second squared. This unit helps us quantify the forces we encounter in everyday life. Now, let's explore the different types of forces. Gravitational force is the attraction between any two objects with mass. It's what keeps us grounded on Earth and causes objects to fall. Then there's electromagnetic force, which arises from the interaction between charged particles. This force is responsible for electricity and magnetism, influencing everything from how your phone works to how magnets stick to your fridge. In the atomic world, we have the strong nuclear force, which binds protons and neutrons together in the nucleus of an atom. It's incredibly powerful, but acts over very short distances. On the other hand, the weak nuclear force is responsible for radioactive decay, playing a crucial role in processes like nuclear fission. We also encounter contact forces in our daily lives. These are forces that arise from physical contact between objects. Friction is a common example. It opposes motion and can slow down or stop moving objects. The normal force acts perpendicular to surfaces, supporting objects resting on them. Applied force is simply the force you exert when you push or pull something. To visualize these concepts, consider some real-world examples. When you push a cart, you're applying a force that makes it move. Throwing a ball involves a force that propels it through the air. Gravity is constantly at work, pulling everything toward the earth, while friction acts when you slide a book across a table, slowing it down. Understanding force is essential because it's the foundation of how we interact with the world. Whether you're driving a car, playing sports, or even just walking, forces are at play, shaping our movements and experiences.